Welcome back to part 2 of Module 9, Lesson 3, where we're working with areas of composite figures. And now we're going to take and work on another concept, the area of the shaded region. We have a video to walk us through this. Let's take a look at it.
To find the area of a shaded region, first find the area of the entire figure. In this example, the entire figure is a rectangle. Multiply the length, 8 meters, by the width, 6 meters, to find the area. The area of the entire figure is 48 square meters. Next, find the area of the unshaded region. The unshaded region is a circle with a radius of 4 divided by 2, or 2 meters. Multiply pi by the square of the radius to find the area. The area of the circle is approximately 12.6 square meters. Finally, find the area of the shaded region by subtracting the area of the unshaded region from the area of the entire figure. The area of the shaded region is approximately 35.4 square meters.
Alright, that's pretty straightforward. Enjoyed some peaches while we were watching that. Let's see what we can do on these type of problems ourselves. For example 2, we're going to be looking at the area of a shaded region, and it's coming up. Here we go. We have a shaded circle with an unshaded square inside of it. So to work this, the first thing we need to do is find the area of the circle. The next thing we need to do is find the area of the square, and then from there we're going to subtract the area of the square from the area of the circle. You can see they did the formula for area of the circle, pi times radius squared, plugged in what they knew, and got the area of the circle, which is going to be 113 4/100ths of a meter. And so you would type that in right there, 113.04. Check it. That part checks. Next, we're going to find the area of the square, which was areas was side times side or side squared. 8.5 squared gave them an area of the square of 72.25 meters squared. And now all that's left to do is subtract those two numbers. So when we subtract them, we're going to get, let me take and actually do that off to the side where I can work it, 113.04. So I have 113.04 minus, what am I subtracting? 75.25. 75.25. We're going to do some borrowing here. Let's knock that one down to a 2, which would make that a 10, but that 10 is going to become a 9, making that a 14. 14 minus 5 is 9. 9 minus 2 is 7. Your decimal comes down. Oop, we got to borrow some more. A 0 and a 12. 12 minus 5, that's going to end up giving me 7. And now I need to borrow one more time. 10 minus 7, that's going to give me 3. So the area of the shaded region should be 37 79/100ths. 37.79. And check. Oh, hold on. And then therefore we're going to put it our 37.79 here as well. And somewhere I did a mathematical boo-boo. Let's check my work by taking 113.04. No, missed that. 0.04 minus 72.25, and whoops, it was 40.79. Not sure how I got that far off. 40.79 it is. Totally my bad. Now technically, this is supposed to be your problem. This is a pretty ugly problem. So I'm going to work it for you and show you how to do it. I'm going to start off by taking a screen grab of the drawing, and then we're going to start working through the pieces we have. So we're going to take and copy that, and I'm going to jump over to my scratch paper. I'm going to paste that in, and we're going to take and resize that some. Alright, the good place to start. Now I'm going to do the easy part first, which is going to be the area of the rectangle. A rectangle is going to be length times width, so the area of the rectangle is going to be a length of 12 1/3 inches times a width of 5 2/3 inches. Therefore, the area is going to equal 2. We're going to keep do the Texas thing. 3 times 12 is 36, plus 1 is 37 over 3, times 5 times 3 is 15, plus 2 is 17 over 3. And now we're going to multiply that out, which is going to give us 37 times 17 is going to be 629 over 9. And I'm just going to leave it there as an improper fraction and hold on to it for a little bit. Now I have to do the next part where I'm going to find the area of the triangles, because I have to subtract all 4 of those triangles from this figure. And I want to point some stuff out to you. Let me take and I'll do that mark. And I want to show you, if I was to take that triangle that they have given us the size of and actually flip that whole thing over, you can see that we have got a base of 1 1/3 inch and a height of 1 1/3 inch, because your base and your height, those meet at right angles, and because I have that base and height here, I have what I need in order to solve the problem. Now I'm going to take and flip it back, stick it back in its hole, and it's time to work the triangle problem. The formula for the area of a triangle, there's several of them, but the one I'm going to use is the fraction formula, because we have fractions in here, which is 1/2 times base times height. So I have area is equal to 1/2 times the base was 1 1/3 and the height was 1 1/3. Area is equal to now 1/2. We're going to do the Texas thing again. 3 times 1 is 3, plus 1 is 4 over 3 times 4 over 3 again. I'm going to simplify before I multiply. 2 goes into 2 once. 2 goes into 4 2 times. Whoops, didn't mean to make that mark. And now we're going to multiply it out. Area is equal to 1 times 2 is 2. 2 times 4 is 8. 1 times 3 is 3. 3 times 3 is 9. So the area is going to be 8/9. But that is only one of those triangles, and I have 4 of them. So the next thing I'm going to do is multiply that times 4. So I have 4 triangles at 8/9 of an inch for each one. Make an improper fraction, multiply that out, and now I'm looking at 32 over 9 is going to be the area of the entire triangle collection that we're subtracting. Let's go ahead and circle that too. Now it's time to finish our problem. We're going to take our rectangle, which was 629 over 9. We're going to subtract 32 over 9. They were kind enough to give us a common denominator for this one, and that's going to end up leaving me with 599, I believe, over 9. Let me just check that real quick so we don't make a silly mistake. So 629 minus 32. Oh, 597, my bad. So we're going to take and erase that 9 and make it a 7. And now we're going to take and do 597 divided by 9. 9 goes into that 6 times, which is 54. Leaves 5 left over, bring down the 7. It's going to be 6 again, which is 54 again, with 3 left over, 66 and 3/9. So we get 66 and 3/9, also known as 66 and 1/3, which would be our final answer for that rather complicated problem. Jump back over here, type it in as a mixed number, 66 fraction 1 over 3, and accept, and check, we get a happy sound. That is going to be it for this lesson. Get started on your homework. Bring any questions you have to class tomorrow.